roots of polynomials. Our learning goal is to use roots of a polynomial to find more roots. Okay? So we know how to, well, what is a root? First of all, review.
So on the bottom of a plant.
Yes,
The
that's,
base of a number.
no. What's a root?
Maybe that wasn't.
Like that times that equals the number.
Oh.
That's a square root. Perfect square. A root is a 0,
Oh.
a
Yeah.
solution, an x-intercept. Okay, so roots are zeros, solutions, x-intercepts. All the same thing. Okay, set it equal to 0, right? Okay, you set it equal to 0 and solve, but sometimes you got to factor before you solve. And we know that we can use long division. And if we get a remainder of 0, then we know it's a factor, right? And we can use synthetic division, same thing. And we can just factor it. And we've learned some rules with factoring. If the highest degree and the next degree is half, we can just factor it normal, right? We've learned some things like that. And that's the whole point of factoring and everything we've been doing are to find x-intercepts so we can eventually graph. Oh, you pressed snooze? You didn't dismiss it?
It wouldn't let me.
Oh, it wouldn't. Oh, well, thank you for trying. So that was the whole point. So we're going to keep going. Well, we know that sometimes we need starting points. And if they give us one root, we can use synthetic division and find more, can't we? And they've done that. But what if they don't give me any roots?
We find our own.
We do. We find our own. And we have a method to do that. So that's what we're going to do today. Okay, so the method is the possible rational zeros test. Rational zeros test states the possible. Does that mean for sure?
No.
No. Means possible. And what is rational? What is a rational number?
A number that's not a fraction.
No, rational numbers can be fractions, but they can't have square roots.
Oh, yeah.
Okay? So it can be a fraction, but it can't be a square root. That's a non-rational number. It's real, right? But it's not rational. So this says the possible rational zeros. So is this checking for imaginary or complex solutions? No. Is it checking for irrational solutions like the square root of 5 or the square root of 2? No. But it gives me a place to start, doesn't it?
Yes.
Okay. Now, it's an equation, and the possible rational zeros are equal to, and oh, I call these PRZs. Why do I say it's a PRZ?
Because that's just.
Because if you take the first letter of each word and then put them together, you get the 3 letters.
I always get that. What is this PRZ thing? Okay. I don't want to write out possible rational zeros, do you?
Yes.
If we
Probably
would.
right out one.
Okay.
Don't write 'em out,
So what we do is we take the factors of the constant term, plus or minus them, okay, and divide it by the factors of the leading coefficient, both positive and negative as well. So that is only giving us the list of possible. Now that list could be very large, but think about it. Is 20 smaller than an infinite amount of numbers?
Yeah.
Yeah. Okay. So, and odds are you're not going to have to test all 20 unless you're a really bad guesser.
I'm an amazing guesser.
Because it's one of those things that you kind of just figure out. If you're wrong, you stop and you try something else. What is the goal? We synthetically divide and get what as a remainder? 0. So if I'm not going up to 52, I can stop halfway through, right? If the numbers I have aren't going to get me to 52, I can stop. Try another number. And you'll get better at it. So the PRZs for 4x to the 4th plus 13x cubed minus 124x squared plus 212x minus 8 are what? Possible rational zeros. So what is my constant?
Oh no.
What is my constant?
You don't have a con.
Yes, I do too.
No.
Not the A.
What did you say, Austin?
Two.
No.
Yeah, I know.
What's a constant, guys?
One.
What is a
Oh,
constant?
her.
What?
A constant is something that does not change.
Yes.
There's only one number in this whole thing that doesn't change with every x.
-8.
Negative 8. Should my constant always be my last term?
Yeah.
Yes. If it's written
If
in
it's-
standard
yeah.
form, yes. And my leading coefficient should be my what? First term, again, if it's in standard form. And should we always write things in standard form?
Yeah.
Yes.
No.
Okay, so what are the factors of 8?
4.
One.
One,
Two.
two, 4, and 8. Okay? What are the factors of 4?
One.
1.
Two. And 4.
Now, I will let you leave your factors like that, but yes, you do have to write plus and minus in front of all of them. The book makes you write them out. I'm going to show you. The book would tell you that you do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus a half. And then because I'm going this way, right? Because this is all over 1, yeah? Now I got to put them all over 2. So I'd have a half, and I'd have 1 and 2. 4 divided by 2 is 2.
Yes.
And I already had 1 and I already had 2, correct?
Yes.
And I have 4, yes?
Yes.
So now I have to move to 4. So then it'd be what? 1/4. And then everything else is going to go a half, and then 1 and 2. Now, that wouldn't be too bad for this, right? But the only reason it collapsed like that is because I have the same factors in the numerator and denominator, don't I?
Yes.
Think about if I had 1, 3, and 5.
It'd be different.
Think about that list, how big that list would be. Long, right? Because you'd have 4 for each, so you'd have 12 different ones you have to write.
That's groovy.
I don't care. You can list them out like that if you want, but I'm okay just with this. Because I know that you can make 1/2 out of that, right? You see 1/2 in there. So I'm okay with just like this. Okay, so let's try this again. What is the constant of the next problem? Negative for it. Okay, normally the negative matters. Here it doesn't matter because we do plus and minus. Does that make sense?
Yeah.
So 45 is my constant. And what's my leading coefficient? 7. You
You
notice it's the same problem. I just changed.
No, I did now.
Oh.
The,
No, I
the
didn't.
filling of the sandwich is the same.
Where are you like this?
I mean, he's
Do you
not
guys have the
wrong.
problem written down yet?
No.
No.
I don't
Okay.
write down. Oh, I forgot to write down the problem.
Oh, then write it down.
So I was waiting.
Please, Louise.
And try it yourself. See if you can do it.
Alright, do that.
I keep.
Do they have to be in order?
No, but it makes it easier to do. Does that make sense? But no, they don't have to be in order.
'Cause I like doing pairs.
You like to do in pairs. Yeah, see that bugs me. But there's nothing wrong with
You
doing
said
it.
it didn't have to be plus or minus?
You don't have to have plus or minus. Yeah, you're just making noise to make noise.
Oh, a little bit.
Hey, do that.
Okay, so the factors of 45 are what? Plus or minus 1?
Minus 3.
5.
Oh, 3.
Wait.
3 goes into 45. Plus or minus 5.
9.
Plus or minus 9.
15 and 45.
Okay. And actually, I was nice to you because think of a number like 62.
No, you
You don't want to.
No.
Or maybe not 62, but a number that like 3 and 2 goes into it. So you have evens and 4 goes into it and 6 goes into it. You can get a really big amount of them, but they're not too bad.
Going to 62.
What?
Oh.
No, 4, it doesn't, but I'm saying if you got a number that 2 and 3, if 2 and 3 goes into a number, so does 6, right?
What
And then if 4 goes into it too, we've got those kind of numbers, don't we?
Yeah.
Okay. Like 12.
Yeah.
Okay, so over what?
1 and 1.
Plus or minus 1 and plus or minus
7.
7. So this one, I would have 1, 3, 5, 9, 15, 45, but I'd also have what? 1, 7, 3 sevens, 5 sevens, 9 sevens, 15 sevens, and 45 sevens.
Yeah.
Now, the whole goal is to give me some numbers to pick from to do synthetic division to get a remainder of what?
Zero.
Of 0. So I know it's a factor, a 0, a root, a solution, yes?
Yes.
Now, am I gonna start with 15 sevenths to synthetically divide with? No. You are going to do the whole numerator before you do anything with the fractions, aren't you?
Yes.
Are sometimes you going to have to dip into those fractions?
Yes.
Yes. Not in your homework today.
No one wants
Not
to.
very fun.
Yeah.
What else is that?
Okay, so there's a lot up there, so let's just, don't write, let's read and paraphrase, right?
Okay.
Okay, so the concept, the fundamental theorem of algebra. If P of X is a polynomial of a degree greater than equal to 1, then P of X equals 0 has exactly n solutions in the set of complex numbers. We've talked about this before. If I have a degree of 7, how many solutions do I have? My highest degree is 7. What does this say? How many do I have? 7. Does it say they're real?
No.
No. It says it has
Seven.
7 in the real number system. So that includes real numbers, irrational numbers, rational numbers, and complex numbers. Yes?
Yes.
So, how many solutions does this have?
4.
4. Now, it's 3 4 times, but are there 4 solutions?
Yeah.
Yeah, what happens if it's 3 4 times? What happens to the graph? It's an even number. Does it go through it or bounce off of it? It bounces off of it. Okay, so what are all the complex roots of the polynomial equation? So, here it is. There are 5 terms, so we don't have any method of factoring that, do we? Nope. Because if it's 4 terms, we possibly could group it, right? But we don't have any method to do that. So we have to find a way to make it smaller. Well, how can we make it smaller by degree 1? Using what?
Synthetic division.
Synthetic division, right? Because every time I divide synthetically, it decreases by how many? 1 each time. So this we only need to get it down 1 to possibly be able to group it, right? Or if we could get it down 2, we could do quadratic formula, couldn't we? So we need to figure out a place to start. So guess what we're going to list? Our PRZs, so we have a starting point. So I'm going to use up here.
2.
So 2. Oh, that's easy. What are the factors of 2?
1 and 2.
1 and 2. Okay. What are the factors of 3?
1 and 3.
1 and 3.
So that's 1 and 3.
So I could have 1, 2. I could have 1/3 or 2/3. Correct? Everyone see how I just made those numbers?
Yes.
Okay. We probably aren't going to just jump off and say 2/3, are we?
No.
No.
Yes.
Okay. Do I have any holes I got to fill in?
No.
No. So I've got 3, 4, 2, -1, -2. And I do not know why I started clear over there. Probably don't want to. What do you guys want to try first?
1.
-1.
2.
Ooh, I got a -1 and I got a 2. We got both?
-1.
Write all the numbers first. I always just do 1.
-1.
I typically do not start with 1. These are small numbers, so it's okay. But if I just do 1, am I getting big very quick?
No.
No. So this one wouldn't be a bad one to try 1 with, but I love it when we get ones like 12 and 16 and 32 and sort of those. So let's start with 1.
Yes.
How are you going to get anywhere? Does that make sense?
Yes, ma'am.
Okay, so we got 3, -3, 1, -1, 1, -1, -2, 2. Ooh, that was nice.
Oh,
Did that work for us?
I knew it.
Wow, good job, Andy.
No, I think you got one.
Kill had
Well,
the
no, I knew it.
bad answer.
Okay,
Oh, I said 1.
now
You said
we're down to x to the 3rd, right?
Yes.
Now I'm looking at this and I can tell we can't group that. How can I tell we can't group it?
Cause you got 3 and 2.
I got 3 and 2, don't I?
Yeah.
So I don't have common factors that would factor something out and give me something nice. So what you do is you do something called repeated synthetic division. You take your answer and we just do it again. But the thing about PRZs, if your constant, let's say your constant was like 72 before and now it went down to 2. Does that eliminate a lot of possible solutions?
Yeah.
Yeah. So you can reevaluate your possible rational zeros right now. But I still have a 2 for a constant and 3 for a leading coefficient. So did it change my?
No.
No. Okay. And negative 1 is still in a possible realm because it could be a double zero, correct?
Build on
Yeah.
2.
What do you guys want to try now?
-1.
Two.
I did all the calculations in my head. It cannot go wrong.
I like that.
Anybody wants to try 2? Anybody against 2?
Sure.
I don't know what
Yeah.
I wanna do -1.
Okay, so 2. So I got 3, 6, 7. I'm going to stop.
We got
They're
7,
getting
we're gonna have
bigger.
14.
What's gonna happen?
28. We're
It's
gonna
just
gonna keep
keep
going
going.
up.
It's keep going up. So since I tried 2 and it didn't work, and I just stopped because it's just going to keep going up.
1.
So I'm going to change this just to a negative real quick. Might as well try the negative while I've got it there, right? So that changes this to -6. So this changes this to -5, and then 10, and then 11. Do I need to keep going? No, because it's still going up, right?
Yeah.
So you take your eraser out because you have one that works,
My pencils are erased out.
and you erase.
So you know what we're
You
doing?
win some.
And-
you lose some.
-1.
2 doesn't work, right? So look what I did.
Erase it.
You,
Actually, I'm going to go 2 and cross it out because I still could have 2/3, couldn't I?
Yeah.
Yep. Now, if I didn't have a 3 in the denominator, I'd just cross out 2. But I usually will go off to the side and put a 2 so I know I tried it. And that means both of them. I tried both of them, right? So maybe I should do this.
I think we should do a 3rd.
A third?
No.
I think we
I think we should do
-1.
-1.
Let's do -1 again.
-1. The baller right now.
I wrote the answer.
Appreciate.
Now it's a -3, so now it's a -1 instead.
And what does it need to be?
A 0.
So does
It's
this work?
close. It's close.
Did -1 work?
I'm telling you guys.
No.
That
So let's
1/3
try
is gonna be
1
where
since
it's
we're
at.
here. So that would be a positive, right?
That's why we get 2 5.
And this would be 4,
And
and this would be
already
4, and this would be 5, so that doesn't work, right?
Yeah.
Okay.
So let's try
3.
a third.
A third?
I was about to say.
Yeah.
I said
Okay, a
3.
third is still going to be better than 2/3, right?
Yeah. Because the first number is 3.
Okay, so we know plus or minus 1 didn't work either. Right? Oh, wait. Well, -1 worked, but it didn't work again, right? So we're done trying it? So 1/3, you want positive or negative?
Negative.
Negative.
Okay,
Why did you write the negative there?
because it's the page
Oh.
ends.
Oh, I was really-
I was trying to write it here and it doesn't work, see?
That's a shame.
Okay, so 3, a third of 3, a negative third of 3 is -1. So 0, 0, 1.
Ah, rip.
1.
Ripperoni, guys.
Is it gonna work?
No.
Okay, positive.
Positive? So then that would be +1, so this would be 2.
Okay.
And this would be 2/3.
Ooh,
And this would be 3/3, right?
Yeah.
So it'd be 5/3.
gosh, we're really gonna have to do that.
And then we're gonna have 5/9. I don't think that's gonna give me 0, do you?
Yes.
Okay, I got an idea. I want to try 2/3.
Negative or positive?
Let's do 3.
Shut up.
I think 3 is gonna work.
No.
3.
3, there's no 3 up there.
Yeah,
Another
get
big-
exposed.
The bottom
Oh.
is like.
Look at it like a fraction, Isaiah.
There's no 3 in the numerator.
Oh, I thought you had the truth.
No, no. If it's in the denominator, it's a
Just pick
denominator. You
whichever
can't just
number gets it.
Okay, from the denominator.
-2/3.
negative 2/3. Okay, so
Yay.
3. Well, 3 times 2/3 would just be -2, yes?
Yeah.
Or -1.
All day.
So then 2/3.
Oh, golly.
So this can be 5/3.
Yeah. So that'd be a negative.
negative 10 ninths.
Doesn't work.
Positive 2/3. Wow, we are bad. That's good.
So this is 2, right?
Fine, guys. It's gonna work out.
So this is 3.
And then we get.
And then we're going to get 2 again.
Evan, I thought you were good at guessing.
And then we're going to get what?
3.
3.
And then we're
And
gonna
we're going to
get
get 2. Okay, so the one you did last, because you were trying to avoid 2/3, would have been really easy to work, right? Now, I'm going to tell you, those things don't pop in your brain until you've done 1.5 million of these. Okay?
Have you done 1.5 million?
Like,
Probably.
1.5 million or like 1.5 million?
No, 1.5 million. Okay. So, we found out that positive 2/3 works, right? So this was 4 cubed. What do we got now?
Wow.
Squared. So I have 3x squared plus 3x plus 3.
Yeah.
And I
Yeah.
can factor out a 3.
Yeah.
But can I factor what I have left?
That was 1.
Can I factor that?
No.
No.
Because the factors of 1 do not add to 1, do they? No. So I have to use the what?
Quadratic formula.
Quadratic formula. Ooh, with a bunch of 1s. That's pretty easy, right?
Mhm.
Okay, so quadratic formula
So minus
tells me
one.
-1 plus or minus the square root of 1 minus 4 over 2.
Yes.
So this is all -3.
Mhm.
So I get x equals -1 plus or minus the square root of 3i over
4, 2.
2 and -1 and
Either.
I wrote those kind of close, sorry. So those are my answers. Now, which one of those are real?
First
1 and -1 and 2/3.
-1 and 2/3. Which ones are rational?
Add the x equals.
-1 and 2/3.
-1 and 2/3. They're both real and they're both rational, correct?
Yeah.
Which one is complex?
The 1 and the I.
The one with the I. So -1 plus or minus the square root of 3i over 2. So, synthetic division has its place and this is its place to get us further down where we could factor things by using grouping, quadratic formula, or just basic factoring.
Please.
Now, are they all going to take you that long? No.
I hope
I hope not.
so.
But you thought it was going to be quick. There was only possibility of 4 different things, right?
Yes.
But
It was not quick.
it was not quick. I agree. Why does it always go backwards?
Because it likes to.
Click backwards.
Okay, what are all the complex zeros of the polynomial equation?
I don't know why don't
1,
we just
2,
No,
5.
just stop. I can use the possible rational zeros. That's what Evan was going for, right? He was going 1, 2, 5, 10. So my numerator and my denominator is 1. So 1, 2, 5, 10. We're done.
Can't you
But-
split that by grouping?
Can I factor it by grouping? If I can factor it by grouping, should I?
Yeah.
Yes. Okay. If I factor this by grouping, it would have to be the first 2 and last 2 probably.
Yeah.
Or maybe not. We could probably mix it up. But do you want to do first 2, last 2?
Yes.
Yes. Yes.
No.
So first 2, what do I get?
You
X
take
squared
X.
and then parentheses x math 1, x math 2.
Yeah, 2, not 1. My
12
pen
now.
doesn't like me up there. Okay, and
plus
then
5,
plus 5.
x math 2, and parentheses
Kelly, you're not.
x squared plus 5.
Okay, I'll stop that. Thank you. And then x minus 2.
Yes.
So I said everything equal to what now?
0.
Okay, could I have done, well, first of all, I'm going to do this. Okay, equals 0, right?
Mhm.
So I get x squared equals -5, and x equals 2.
Yep.
And so I take the square root of both sides here,
Yeah.
and I have x equals 2 and plus or minus the square root of 5 I. So I took the square root.
Mhm.
Now, if I would have done possible rational zeros in synthetic division, so PRZ. So we said 1,
2, 5, 10.
2, 5, 10. All over 1, right?
Yes.
Okay. If I would have done that, could I have gotten one of my answers?
Yeah.
Yes. Okay. I would have had to then do the quadratic formula, obviously, to get the square root of 5i, right?
Yes.
There are problems. We could have done it, and we could have found it, and it would have been fine. There are problems in your textbook that you can't do possible rational zeros because you don't have any rational answers. So is it important to know when I can factor, when I can group, when I can do those other things? Okay, so make sure when you get to a problem, you just don't jump immediately head first into the shallow end. Got it?
It goes into the shower.
It- Yeah, that's the whole point.
Shallow.
Shallow end. Because especially if I had a lot of factors, could I spend a lot of time and find out there's no possible rational zeros?
Yes.
Yeah, and you're like, oh, I could have just done this. Okay, conjugate roots, and we've talked about this before, and there's a lot of words up there again, and I'm just going to tell you if one of them is there, the other one has to be there. If A plus the square root of B is there, what also has to be there? A minus the square root, because that plus and minus came from taking the square root, right?
Mhm.
So we've talked about conjugate pairs before and how they have to be there, don't they? So if I said that x equaled the square root of 7i, what also has to be there? What's the conjugate to square root of 7i? Well, this is plus, the minus the square root of 7i. They have to be there. Got it? If I have 6 minus 3i is a factor, what also has to be there? 6 plus 3i. Got it?
Yes.
If I have x equals the square root of, or negative the square root of 5, what also has to be there?
Positive square root.
Positive square root of 5. It doesn't matter. Those conjugate pairs have to be there. And they will only give you one. And you have to know that the other one comes along with it. Okay? So it's going to say, if these are the zeros, give me a second degree polynomial. But it's only going to give you negative square root of 5. So what do I also know? Positive square root of 5. So what factors did these come from? Remember we set them equal to
X
0 and move them
squared.
back, right? So x plus the square root of 5 and x minus the square root of 5. Because you have to add it back over, subtract it back over, right?
Yeah.
Now, where did this one come from? X plus square root of 7i and x. Okay, those are easy. What about this?
The square root of 3i.
So, when I put these back in a factor, I have to subtract the whole thing over, yes? On both of them? So when I do that, I'm going to show you this whole process. So it would be x minus 6 minus 3. That was bad because 6 and 3 goes in there, right? That wouldn't be right. Oh well. 3i. And I have x minus 6 plus 3i. Okay, what do I need to do with those negatives?
Distribute
I need to distribute it, right? So I get x minus 6 plus 3i and x minus 6 minus 3i. Do you still see that conjugate pair in there? You still see it? Okay, but this is how it works. A lot of people mess this up because they want to put a plus, like they wanna put a plus, I don't know, one of these sixes, they wanna change the sign of the six. Does the sign of the six change?
No,
It's the only on that second half, isn't it?
Okay.
And then how would I get the polynomial from the factors? I would do what with these two things? I'd multiply them out, yes?
Mhm.
This is the only time I like to use the box. It's the absolute only time I like to use it because it organizes all this. The whole point of the conjugate pair is when I'm done, am I gonna have any i's left?
no.
No. Am I gonna have any square roots left?
No.
No. Okay, so this would be x squared minus 6x, 3xi, negative 6x, plus 36, minus 18i, minus 3s. I know I'm going really fast, but 18. Oh, there's an I. Yes? Yes.
Yeah.
And then minus 9i squared.
Mhm.
So my 18 and my 18 reduce, my 3 and my 3 reduce, and this I squared makes that 9a positive. So I have x squared minus 12x plus 45. Did that give me a second degree polynomial with only giving you 1 0 at the beginning?
Yes.
Yes, because you knew the other one had to be and you had to multiply it out. I'm just gonna take a little bit of time.
Yeah.
Yeah,
How did you do that again?
we'll do it again. We'll do it right now. Okay, so what is the quadratic function p with rational coefficients and standard form such that p of x has, p of x equals 0? Oh, that p of x equals 0, not a root, sorry, has 2 plus 5i as a root. So if it has 2 plus 5i as a root, what do we also know?
Negative.
2 minus 5i. Now it says quadratic, so what degree is this?
Second.
Second. So if I have 2 factors, am I going to have a second degree? Am I going to be good? Yeah. Okay. So I know that x equals 2 plus 5i and 2 minus 5i. So we're going to go through and set up this whole thing. Now remember, this is a quantity, yes? And to make factors, zeros into factors, I have to move them back over to the other side of the x, right? So I subtract the whole factor to move them back over. So I'm going to have x minus 2 plus 5i and x minus 2 minus 5i. I had to move all the factors over, yep. Now what? Distribute the negative. So I will have x minus 2 minus 5i and x minus 2 plus 5i. Do you still see the conjugate pair there? Should you stop and check? Austin, did you have a question? No. Okay. Ethan, does this make more sense now? Okay, now those parentheses mean I do what? Multiply. So you can just distribute whatever. It doesn't matter to me what you do, as long as you do it efficiently and correctly. Does it matter which one I put on the top or the side?
No.
No. Okay, so you do it and I'll do it. So I don't say things out loud.
The bottom three looks like the bottom five looks like a 3.
Sorry.
I was just letting you know. Thank you.
Whoever has their feet on that, take it off, please. Somebody's got their feet on the bottom rack. the seat in front of them and they're squeaking it. Okay, I got x squared minus 4x plus 25.
Yeah, how do you
How do I do what?
get the final answer?
You got 29.
Or 29, did I say 25?
She puts the
I
numbers
just combine
together.
like terms.
If I finish crossing out the minus paper.
Because that was negative 25I squared, right?
Yeah.
And the I squared made it a positive?
Oh.
So if I did this right, will all of my imaginary numbers be gone?
Mhm.
Yes. If you were left with an I in there, you did it wrong. Whether it was your multiplication, or you set up your factors incorrectly, or if you changed. Guys, if I would have conjugated the 2 as well, like changed the sign on the 2, would this have worked?
No.
No. On Thursday, when I did these notes with fifth period, I made a mistake because I just jumped straight to the finished factor. I didn't do that middle step. And I did make a mistake on that. I had one positive and one negative, and they didn't reduce, so I knew I did something wrong. So, I personally, when I do something wrong, I just start all over, because if I go back and try to check my work, I save it and then cover it up and do another, and then do it right, and then go back and look. Because if I go back and try to just fix what I made the mistake, guess what I tend to do?
That's up to
Make the same mistake. So it's important to go back and look and see what your mistake was, but if you're in the middle of it, it doesn't always help us to do that. Questions before I move on? Are you good?
I don't understand.
Well, you were in the bathroom for the whole thing.
Use the box.
That's basically it.
You could,
Up with all these numbers
what numbers?
up there.
Up here?
Oh, you just boiled them into.
Yeah. We set up the factors, and then we got rid of the parentheses by distributing the negative, and then multiply. We'll do another one. I think, maybe not. Yeah.
Let's do another one.
Okay. What is it?
5 minus 4i.
5 minus 4i. Okay, someone see that?
No. Yes, I do
Yep.
see that. Okay.
So I have x equals 5 plus 4i and x and 5 minus 4i's. 4i's. Do not mistake this parenthesis saying that is the factor. It's not a factor. It doesn't have an x in it, does it?
No.
So how do I get the factor?
Oh. By.
I have to bring it over, right? So you guys try to make your factor. Try to make your factor on your own.
I physically cannot.
Yes, you can.
I think you physically can.
You physically can, maybe mentally cannot, but you physically can.
I don't think. I'm basing it off of. Then we can. You want us to do the whole thing?
Keep going. You got your factors.
Actually stopping exactly 0.64.
Okay, I guess I'm done.
I think I'm done. If I get it wrong, Kale.
Oh, my bad, Kelly. I was
You know what that
only
means?
0.63.
Keep going.
Okay, did you get that? Right?
Yeah.
Yeah.
Wait. Yes. Think you're funny, Kale?
I thought you were kind of
I
Gentlemen. Work.
Takes more than that. to
More
go
work, less
whole.
talk.
No.
Don't encourage him by laughing.
And then finish it up. Get your polynomial.
Put it in a box.
You got the polynomial?
I don't know how to put it in a box.
You know how to do the box? Okay, what's our box? What by what? How many is in each? 3 and
Yeah.
3.
Yeah.
So
I
3 by 3.
understand that.
Okay.
And then X. Then that. Obviously.
So you use x, negative 5, negative 4i.
Okay.
And x, negative 5, 4i.
Does it matter, like,
If you put the, on the
No.
side or the top,
Is it?
nope.
Yeah,
Okay.
It's multiplication, it's commutative.
so as long as
X
we like
squared.
don't mix up.
Yeah, as long as you
all
don't mix the two factors,
the then you're
you're
fine.
good. I will always make my box longer
I hate
than taller. That's my personal, but if it's a 3x3, it's the same, right?
No.
Wait, I got an answer, and I think it's right.
So do I.
So do I.
Shut
I
up.
don't know if I got it right.
You like the PBJ.
Wait, why would that not? Oh, whoops. I'll go with that.
How did you get
It should be minus 16.
Oh.
No.
No,
Why?
it should be
No.
negative 16I squared, and the I squared makes it a positive.
See, if I knew how to multiply 4 by 4, I would have got the right answer.
So,
But I
It's only a
didn't.
3x3.
No,
Wait.
4 times 4.
Oh,
Oh.
yes.
So
Elena.
what did you say about? Because I thought the same thing as
Okay, this was negative 16I squared,
and then this
but
one
the
is
I
that.
squared makes it a positive 16.
Okay.
Okay, you notice what didn't I fill in?
The rest of
The
them
ones
are
that are gonna
class.
cancel out.
Yeah,
The ones that we're
Reduce.
gonna reduce out, yes?
So we
Now-
don't have to?
That's not good, because that's my check if I did it right, isn't
That's
it?
not showing your work.
Because if I left those things out, and I didn't put these in here correctly, it wouldn't be brought to my attention, right?
Yeah,
But did you guys get the same thing?
eventually.
Now, if you
There we
read
go.
these, yeah, once you learn to multiply 4 times 4. If you read these, it says a possible answer. Could I put a 10 out here?
You could.
If I put a 10
Nice.
out there, listen, if I put a 10 out there, does it change my zeros?
Yeah. Maybe.
No.
well,
No,
that's not a
Because
0.
there's not a variable with 10,
Yeah.
is there?
No.
It's just a scalar. So if I put a 10 out there, that would make it 10x squared minus 100 x plus,
400.
4100.
right? No, I multiplied by 100.
41
Okay, but is that going to change my zeros?
No.
No. So there is an infinite number of possible answers for this, but I can bet money that nobody's going to put a negative 16 out there.
Why?
I will.
Ow!
Because why would you?
I don't know, because you can.
What?
Why not?
Does that just make it more
Yeah, well, it doesn't make it more difficult. Does it open you up for more error or whatever?
difficult?
Yeah. So technically, there's an infinite number of solutions for this, but this is probably the one that 99.9 people are going to give you.
97.
But what does the book kind of give us?
They're going to say a possible solution is,
Oh, okay.
but that's why they say it's a possible solution. Okay, now we have a degree of what?
That.
4. And I don't know what that Q is there for. Oh, that should probably have a Q of X.
Oh, naughty.
Yes?
I don't know.
Q is just the function name.
Oh.
The other ones were P for polynomial. This one's just Q.
For what?
For queen.
Yep,
Quadratic.
I'm the queen.
Yes, queen. For quadratic.
Yes, queen.
Okay, so it needs how many factors? If it has 4, if it's a degree of 4, how many factors do I need?
4.
4. Okay, they tell me that one of the zeros is 2 minus the square root of 3, and one of them is 5i.
Oh.
So what do we know? That x equals 2 plus the square root of 3
And then minus the square.
minus the square root of 3,
Yes. And then
And
there's a 5i.
5i and
Minus 5i.
minus 5i. So, do I have 4 zeros now?
Yes.
Do I have 4 real zeros?
No.
How many real zeros do I have?
Two.
And I have 2 complex. Now we're not gonna have time to finish this whole thing.
Yeah, we
But-
will. You're being a silly
No,
goose.
because I keep having to wait for you guys to be quiet. So I'm gonna have x minus 2 plus the square root of 3, x minus 2 minus the square root of 3, x plus 5i, and x minus 5i. Correct? Now, when I do this, I can't multiply all four together at one time, can I?
No.
No. I have to multiply these two
And those two.
and these two, and with my answers, multiply those together. And I will get 1, because this is going to be quadratic, and this is going to be quadratic, yes? And a quadratic times a quadratic is a quartic, yes?
Ew.
Now,
What the heck?
I feel the same way.
okay, a quartic is just 4. Now, I want to show you this one real quick, because we haven't done a square root. But when we're done, are there going to be any square roots left? No.
It shouldn't be.
Okay, this is going to be really easy. This is going to be x squared plus 25.
Yeah, I agree.
Because it's the sum of squares. Haven't we seen that over and over?
Yep.
Okay, so now this one, let's do it real quick. And I'm going quick so we don't hopefully run out of time.
Go quick, 'cause I'm fast.
You know how distracting you are, Austin, to everyone's learning and my thinking?
None? No, godly. Maybe.
Okay, so look what happened to all my square roots.
They
They got canceled out.
Okay, and what is the square root of 3 squared?
Nothing. 3.
3.
3.
And it's going to be negative 3.
Boom.
Okay, so I'm going to have x squared minus 4x plus 1. And I would take this times this. So that box would be a 2 by 3 if you're going to use a box.
Okay.
Or what? Never mind. See you.
That's exactly what I was gonna say.
I got it, Taylor.
And I will, if you guys be quiet, I'll finish the problem and post it in the video. But if you're going to be noisy, you're not going to. Oops, I forgot my square.
Oh, you're gonna do it first.
I was just going to do it so I can post it in the video.
Where do you get the 4 and the 1?
Where did I get 4? This was negative 2x. Negative 2x is negative 4x. And this negative square root of 3 squared is negative 3. So 4 minus 3 is 1. Oh, shoot.
I got it.
Thanks, Carol, for just looking at it.
I messed up, so I ran out of room. There you go. That's fine. I'm just stopping the video. And it probably will go.